The universe really likes its information. It doesn't like to create any new information, and it doesn't like to destroy any of its existing. In fact, like is far too weak of a word. As far as we can tell, information can neither be created nor destroyed. Information throughout the universe simply persists. We mean that there is a fixed amount of information in the universe, and that, while it may be changed, it can neither be created nor destroyed. Say you write something on a piece of paper and then burn it. In our day-to-day life, this would be considered destroyed or gone. However, if you knew all of the factors coming into play, all initial conditions, and could collect all of the ashes, smoke, and heat, you could technically recreate the paper in its original form. This is important to know because the information paradox prevents just that. It instead seems to destroy information on a fundamental scale, which would break the laws of physics as we know them today. In this video, we will take a look at what is meant with information. What is the information paradox, and possible solutions to it. But before that, don't forget to give this video a thumbs up and subscribe to never miss another journey through space. First, we need to decide what we mean by information and why it ought to be preserved. Physics is ruled by determinism. We can use the laws of physics to predict the future behavior of a system. That's kind of the entire point of physics. Whether it's a particle sitting in a box or a complex chemical reaction or the whole entire universe, our knowledge of physics allows us to make firm, reliable predictions that take our knowledge from the present into the future. In physics, information refers to the details or characteristics of a system that can be used to describe its state or properties. This information can include things like the positions and speeds of particles, their energy levels, and other factors that determine how a system behaves. And that same technique allows us to dig into the past. If we know all there is to know about a system, then the same laws of physics that extend into the future also extend into the past. We can run the clock forward or backward, seeing how that system has behaved or will behave with equal ease. It's this reversibility that allows us to make the leap that information is preserved. If I know everything there is to know about a system, the positions and velocities of all the particles, their spins and electric charges, and all the other stuff, then the laws of physics tell me how all those particles will behave past and future. Thus, the raw information of the system, everything there is to know about it, is preserved across time. It just gets rearranged, not created or destroyed. At first glance, black holes seem to treat information innocently enough. Stuff falls into black holes, along with their information. From the point of view of an external observer, us watching from a safe distance, nothing ever falls into a black hole, it just gets pasted onto the surface. That situation isn't that big of a deal for information, except when the black hole evaporates, which creates a tiny problem. As Stephen Hawking first discovered in the 1970s, black holes aren't entirely black. They do glow just a tiny bit. What's more, this conveniently named Hawking radiation is completely thermal. It's just random heat, just like your body gives off. That means that the amount and temperature of the radiation emitted depends only on the mass, spin, and charge of the black hole. Nothing else. No matter what you throw into a black hole, from books to cats to spaceships, its Hawking radiation will stay the same, which is fine. The information on the surface is still there, minding its own business. But as the black hole produces Hawking radiation, it loses energy, which means it loses mass, which means it eventually disappears, along with all the information it was carrying. So if the information didn't leak out with the Hawking radiation and the black hole goes away, what happened to all the information? We don't have a resolution to the black hole information paradox, but that hasn't stopped starry-eyed theorists from dreaming up a host of potential solutions over the decades. Maybe, for example, information is preserved after all. Although this may seem like a simple statement, it involves rewriting almost all known physics, and black holes are the only places where we've run into trouble with this whole information preserving thing. So is it really worth reinventing all our physical knowledge just to accommodate this one special case? And yet, we've had to rewrite all of physics before, so it's not like it would be the first time, and black holes are very compelling objects. Or maybe Hawking radiation isn't all it's cracked up to be. Maybe somehow the information stuck to the surface of the black hole does end up threading its way into the emitted radiation. Maybe Hawking's original analysis was too simple, and by careful observations of the radiation we could painstakingly reconstruct the books and cats and spaceships that fell in. While this would rescue all of known physics, nobody has been able to find a satisfactory way to actually, make this happen. Perhaps information doesn't get stuck to the surface, but instead is left behind in some sort of crunchy nugget just as the black hole finishes evaporating. That sounds lovely, but again, we have little to no idea of how this would actually work. Or maybe it's something even wilder, like the information getting funneled into another universe or looping back in time. What's exciting about this paradox is that all of the potential answers lead to new physics. No matter what, if we resolve the paradox, we'll do so by learning something new about the universe. Thank you for joining us on this cosmic journey today as we delved into the information paradox. If your curiosity was sparked, don't forget to show your support by giving this video a thumbs up, and if you're new here and hungry for more space exploration, consider subscribing to our channel and becoming a part of our passionate community. We'd love to hear your thoughts, questions, or even ideas in the comments below for our next adventure. Our cosmic voyage doesn't end here. Stay tuned for more captivating explorations into the universe's secrets. Until then, keep looking up, keep dreaming, and keep exploring. And thank you for watching Daily Space.